We're all blown away by what AI can do these days, right? But there's a huge piece of the puzzle we just don't talk about enough, and that's security. Because the second an AI leaves the lab and hits the internet, the game completely changes. It goes from being a brilliant project to a prime target. So today, we're going to pull back the curtain on where the real fight for AI safety actually happens. So let's just imagine for a second, you've done it. You've built a game-changing AI that's going to change everything. But here's the million-dollar question, isn't it? Is it actually safe? Well, to get to that answer, you've got to understand the journey the AI takes, from its very sheltered, very safe upbringing to its release into the wild, wild west of the real world. You see, every single AI starts its life inside this protective bubble. It's trained in a super secure, controlled lab, where every piece of data it sees is handpicked and trusted. But the moment you deploy it, poof, that bubble bursts. And suddenly, it's exposed to everything and everyone out there. That's when the fight for its security really kicks off.
And this right here really nails the problem. In the lab, the AI is incredibly powerful, but it's also completely naive. Think about it. It's only ever seen a perfect diet of clean, trusted data. It's like a brilliant student who's only ever taken open book tests with the answers right there. The real world, though, that's a closed book final exam, and this AI has never seen anything like it. It's just not prepared.
Which brings us to this, the single most critical point in an AI's life, the moment of exposure. We call it deployment. And this isn't just some techie step in the process, oh no. This is when the AI leaves its safe harbor and gets plugged into the internet, connected to potentially millions of users, and of course to adversaries who are just waiting. And I mean, just look at this contrast. It says it all, doesn't it? On one side, you've got the training environment. It's a fortress, controlled, trusted, and totally isolated. And on the other, you've got the real world. It's a battlefield, chaotic, adversarial, and wide open. It's that jump from the fortress to the battlefield that turns a brilliant invention into a massive security risk.
Okay, so the AI is vulnerable, but what does that actually mean? How do attackers actually take advantage of this? Well, they've got a whole bag of tricks, a whole arsenal designed to poke, prod, and ultimately break these systems. Let's look at some of their go-to moves. So the most common way in is through the API. Think of it as the AI's digital front door. Attackers can try to just kick that door down with a flood of bogus requests, or they can get clever and try to pick the lock. This is where you hear about things like prompt injection, which is basically social engineering for an AI. You're tricking it, you're sweet-talking it into breaking its own rules and giving up the keys to the kingdom. And then there's the really sneaky stuff, inference attacks. This is just incredibly clever. An attacker will ask the AI thousands of seemingly innocent questions, and by studying the tiny patterns in its answers, they can start to reverse engineer how it thinks. It's kind of like a spy figuring out a top-secret recipe, not by stealing the cookbook, but just by tasting the final dish over and over and over again. And this leads to some pretty terrifying outcomes. You've got model extraction, which is basically high-tech identity theft for an AI. They can steal your multi-million-dollar model. Then there's membership inference, a huge privacy breach where they can figure out if your specific data was used to train it. And finally, adversarial evasion, where they design the perfect phishing email that's literally invisible to your AI's defenses. And of course, let's not forget the most straightforward risk of all, plain old data leakage. Once it's live, an AI can become a leaky faucet of confidential info. With just the right questions, it might accidentally blurt out sensitive training data. We're talking customer lists, internal memos, you name it. It could even cough up bits of its own source code or secret company formulas. And I really want to drive this point home. This is not just a theoretical risk. This stuff is real. Using these exact techniques, an attacker could work to figure out if your personal, private medical record was one of the documents used to train a hospital's big new AI. Suddenly, the stakes feel a lot more personal, don't they? All right, so that's the threat. And yeah, it's pretty daunting. But it is not hopeless. We can absolutely fight back. The strategy is basically a 1-2 punch. First, we build a fortress around the AI the moment it's deployed. And second, we never stop patrolling the walls, always on the lookout for trouble. So building that fortress means putting up layers of defense. You start by locking the front door, the API, with strong authentication and rate limiting to stop those brute force attacks. Next, you gotta have filters to check everything coming in for threats and to sanitize everything going out so nothing sensitive leaks.
Then you harden the whole environment around the model. And finally, you give the AI a set of hard-coded rules, we call them guardrails, that it absolutely cannot break, no matter what.
But here's the catch, right? You can build the world's strongest fortress. But attackers are clever. They are always coming up with new ways to get inside. So building the fortress, that's just step one. The real fight is the one that happens every single day after that.
And that's where the ongoing patrol comes in. This is so crucial. We're constantly on the lookout for new attack patterns, like a guard on the wall spotting a new kind of threat. We're also doing our own attacks, called adversarial testing, to find our own weaknesses before the bad guys do. All of this intelligence gets logged and fed right back into our security systems so we can patch our defenses and update the AI's rules in real time. It's a nonstop cycle. Defend, learn, adapt, and repeat. Okay, let's bring this all together. When most people think about AI security, their minds go to the algorithm or maybe the training data. But the real front line, the place where this whole battle is either won or lost, is actually somewhere else entirely.
The true front line is what we call the operational perimeter, and it's built on the two things we just talked about. First, a secure deployment, because that is the AI's very first contact with real-world attackers. And second, continuous monitoring, because those attackers never, ever sleep. These two things, together, create the shield that actually keeps the AI safe in the long run.
So if there's one thing you take away from all this, let it be this. Securing an AI isn't a project with a finish line. It's not a box you just check off a list. It is a constant, vigilant process that starts the second the AI goes live, and it never, ever stops. It's a battle that's never truly won. It just has to be fought, day in and day out.
And that kind of leaves us with one last, pretty chilling question. As these incredibly powerful AI systems become part of everything we do, running our hospitals, managing our finances, shaping our world, who exactly is standing guard on that wall? And maybe more importantly, are they doing enough to keep us safe?